Hi friends, welcome to Instrual. So this is the 102nd episode in the space series. So today's video is about the cosmic microwave background radiation, or just the CMB for short. The CMB. When you searched up the term universe, you might have seen this oval-shaped thing with random blue, red, green, yellow lines. This blurry like image thing. So this is an image, that means a visualized image which was transferred into the visual spectrum so that we can see. So this is just an image of this cosmic microwave background radiation, which is a remnant, a footprint of the early universe and the Big Bang. So let's begin. Okay, let's just rub it. So first we need to talk about the Big Bang, of course. The Big Bang, the BB for short. Okay, so when the Big Bang, of course, banged, lots of light was sent around, and of course light was created for the first time as well. So this was not exactly light. This is electromagnetic radiation, in which light is one form. Yes, so electromagnetic radiation. So what happens is, after millions or billions of years, this originally very high frequency light will become microwave radiation. Microwave particles. Yeah, microwave radiation. So what happens is, this is a high frequency wave. Okay? And this is a low frequency wave. It is slow like this with smaller waves and not so energetic. So slow. In the electromagnetic spectrum, the visible light is in like the middle of it. In this side are very high types of electromagnetic radiation, while here there are low frequency electromagnetic radiation waves. So here there are gamma radiation, X-ray and infrared, things like that, ultraviolet. And while here there are infrared, microwave and radio and so on. Yeah. So and microwave is here. It has a lower frequency than normal light and all of these more powerful, dangerous types of electromagnetic waves. So what happens is, slowly but surely, due to a thing called redshifting, this high energetic light will turn into less energetic microwave light. But how does that happen? So this light was very high frequency. So it was like this. Yeah. So but surely as the universe expanded, it started to stretch more and more. Like, take this for example. The early universe was like this. But slowly but surely the universe started to stretch out like this. Distances between points became bigger and bigger, from a few centimeters in the first few milliseconds to lots of light years in just a few minutes. Yes. So this is practically redshifting, how it happens. So because of the stretch, these high frequency waves will slowly start to become lower and lower frequency, and yeah, microwave radiation is formed. So in the present day, microwave radiation is here, but slowly but surely later in the future, this microwave radiation will slowly become radio wave until we can't see it anymore, even with other forms of light. So we can't see this radiation with our naked eyes. It is completely in microwave electromagnetic radiation. So we use microwave cameras to see this wavelength. There are a few probes sent out to see the cosmic microwave background. So such as the WMAP, the COBE or Planck. Yeah. So these were sent out in Earth's orbit to see how this cosmic microwave background radiation is, how it looks like. Yeah. But okay, let's just rub this. You might have seen in those images that it's not exactly completely plain. It's like there's a lot of red, there's a lot of blue, there's a lot of other colors. Yeah. So it was completely random at that time. Yeah, you could have seen it. So there was blue, there was red, there was green, there was yellow, and pretty much many colors between blue and red. But what did these colors mean? So red means there's a high frequency of light, while blue means, wait, I'll use blue. Okay, near blue means lesser frequency of light. Yes, so here there's a lesser frequency, and while here there's a higher frequency. Yeah, so this is practically how this was made. But why is it like this instead of being just plain smooth? So let me explain. In the early universe, just after the Big Bang, for like 378,000 years, there were no atoms at all. It was just completely charged ions, particles, which were not fully atoms at all. Yeah, such as protons, protons, neutrons and electrons would just casually hang around without making any bonds together because of the intense heat, a very high heat. So there's a type of scattering known as Thomson scattering, which happens because of charged particles such as protons, ions or electrons. So in the early days of the universe was very translucent because light would literally bounce off everything, pretty much every particle there was. Yeah. So because of this, there was a lot of scattering, of course. So because of this, in the present day, the image is very scattered. But after this 378,000 years after the Big Bang, the first atom slowly started to create. So such as the hydrogen atom, which was the first one to be created. So the hydrogen atom has a neutral charge. There is one proton and one electron. Minus plus plus is equal to, of course, neutral. This is not in math, of course. In math it is completely different. But in here it is like this. Okay. Yeah. So this was why the scattering occurred. And because of these particles were completely neutral, so Thomson scattering would not occur anymore. This would not happen anymore. So after which the photons would just go continuously without being stopped, without being scattered by this Thomson scattering. So yeah, this is practically what the CMB is, the cosmic microwave background radiation. So bye.